Listen to part of a discussion in an ecology class.
All right, class. Today we're going to discuss a significant environmental issue that has been gaining attention lately. That is ocean acidification. Now, before we dive into the details, let me ask you, what is ocean acidification? What causes it?
Ocean acidification means that the Earth's oceans are becoming more acidic. To be more precise, it is the ongoing process where the pH level of the oceans is decreasing.
Good answer, Mike. So, what is causing it? What's the culprit? Anyone else?
According to the chapter assigned last week, it is primarily due to carbon dioxide, or CO2, in the atmosphere. A certain percentage of CO2 in the air is absorbed into the ocean. Then, the absorbed CO2 lowers the ocean's pH level.
Excellent, Melissa. Now, I will describe it in more detail. You see, when CO2 dissolves in seawater, it forms carbonic acid. This acid then releases hydrogen ions, which increase the acidity of the water. At the same time, these hydrogen ions bond with carbonate ions in the water and make them less available to marine organisms that need them to build their shells and skeletons. Now, what kind of marine life forms are most affected by this devastating process?
Obviously, crustaceans like crabs, lobsters, prawns, shrimps, krill, and barnacles.
Professor, I think shellfish such as oysters and scallops are also negatively affected too.
Both of you have it quite right. I must tell you, however, that it is corals that are most seriously affected by ocean acidification. You know, corals are fundamental to marine ecosystems. They're often called the rainforests of the sea because they support an incredible diversity of marine life. Coral reefs provide shelter, food, and breeding grounds for countless species of fish, crustaceans, and other sea creatures.
I don't understand. I read somewhere that corals are able to absorb CO2. They do this because, 1, their symbiotic algae use CO2 to do photosynthesis, and 2, corals, use CaCO3 to make up their skeletons. To make the CaCO3, corals utilize CO2. So, corals should be capable of coping with increased CO2.
What you just said is definitely correct. However, just because corals absorb and use CO2 doesn't automatically mean that they are immune to CO2. There's 2 things to remember here. First, as corals absorb CO2, so does the surrounding seawater. Acidified seawater makes it harder for corals to form calcium carbonate, or CaCO3, for their skeletons. Second, it also promotes the dissolution of existing coral structures. Furthermore, their CO2 absorption capacity is limited and can't keep up with rapid ocean acidification. As a result, coral growth rates slow down, and their skeletons become weaker.
Oh, I see. Thank you for your detailed explanation.
Okay, like I said a minute ago, corals are a home to varied marine life forms. Also, shellfishes and crustaceans play their roles in the food web and the ecosystem. Ocean acidification can lead to the disruption or even collapse of an entire ecosystem.
Professor, I just thought up this solution. So, if the ocean is acidified, is it possible to alkalize it?
Yes and no. Yes, in theory, it is possible to counteract ocean acidification by adding alkaline substances to the ocean. But no, that idea has been put forward by many scientists. However, it is still experimental and needs more research to grasp its impacts before it is put into practice. So, what do? Well, first and foremost, we need to reduce our CO2 emissions. This means transitioning to renewable energy sources like solar and wind power. We also need to protect and restore natural carbon sinks, like forests and wetlands. Ultimately, it all comes down to how we continue to seek preservation, conservation, and sustainability. All right, now let's start to discuss the recent extensive research on the carbon cycle between the atmosphere, land, and oceans conducted by Dr. Richard Feely and Dr. Christopher Sabine from the National Oceanic and Atmospheric Administration, shall we?